Hi dear friends, welcome back to mathematics online class. In a previous video, we people have taken that two-dimensional CET part synopsis. What are the things we have discussed till so far means in a xy coordinate plane, 2 points are given, distance between those 2 points, distance of a point from the line, y-axis, x-axis and section formula and other things. The centroid of the triangle. What is the centroid of the triangle? Centroid of the triangle means for any triangle ABC, the point of concurrence of the midpoints of the triangle. What is the centroid? Point of concurrence of midpoints of the triangle is said to be the centroid of the triangle. Similarly, in center of the triangle. What is the in center of the triangle? Interior angle bisector. Point of concurrence of interior angle bisector is said to be the in center of the triangle. Next, x center of the triangle. What is meant by x center of the triangle? One interior angle and two exterior angle bisector. A point of concurrence of one interior angle and two exterior angle bisector is said to be the x center of the triangle. Now, in the same manner, now I am just going to the next thing, that is ortho center of the triangle. What is the ortho center of the triangle? Is nothing but ortho center of the triangle. To discuss the ortho center of the triangle, so here ortho center of the triangle, which means that the altitude of the triangle are concurrent. The altitude of the triangles. The altitude of the triangles, altitude of the triangle are concurrent. So suppose any triangle is there. Suppose this is the triangle ABC. Now we need to discuss that ortho center. What is meant by ortho center? The altitudes, the concurrent point of intersection of the altitudes of the triangle. Where is the altitude? Altitude, angle A opposite side, this side is this altitude we need to know. Line is passes through the point A and which is perpendicular to the opposite to the side angle B. Opposite to the side angle A, BC side is that is perpendicular. Now point of concurrence, B opposite side AC is there. For the AC, draw the perpendicular. This is the perpendicular from the point B to AC. Then similarly, point C to the side AB, this is perpendicular. The point of concurrence of the altitudes is called as the ortho center and which is denoted by what is the ortho center of the triangle? In any triangle, the altitude of the triangle are concurrent is said to be the ortho center of the triangle. So here ortho center of the triangle means, suppose for example right angle triangle is there. ABC is the right angled triangle. In this case, what is the required ortho center of the triangle? So whenever right angle triangle is there, just draw the perpendiculars from the point A to the opposite side BC. This is a perpendicular. Angle C opposite side AB is there. This is a perpendicular. Angle B to the value. So this is the perpendicular. Where these all values are intersecting, where the 90 degree is there, which angle is 90 degree is there, that is our required ortho center. That is means here is the one point. What we can point, we can make it here. Whenever the right angle triangle is there, in that case ortho center of the triangle is 90 degree. In which angle is a 90 degrees that on that point the ortho center is lies. Is that clear? This is the required ortho center of the right angled triangle. Then next one is circumcenter. Now the circumcenter. What is the circumcenter? The point of intersection of perpendicular bisector. Circumcenter is nothing but point of intersection of perpendicular bisector. Suppose the triangle ABC is that. This is the triangle ABC. Now, what is the circumcenter? A point of intersection or point of concurrence of the perpendicular bisector. So here perpendicular bisector, the side is BC is perpendicular, midpoint perpendicularly bisect. This is the perpendicular bisector of the BC. Perpendicular bisector of the AC, perpendicular bisector of the AC. This is perpendicular to AC and it is bisect the side AC. AB midpoint and it is perpendicular. This is the perpendicular bisector of the side AB. The point of intersection, the point of concurrence of perpendicular bisector is said to be the circumcenter of the triangle. What is the circumcenter of the triangle? The point of concurrence of perpendicular bisector. Point of concurrence of perpendicular bisector. So for any triangle, suppose the triangle is right angled triangle. Suppose the triangle is right angled triangle. In that case, where the circumcenter is lies, perpendicular bisector. For this side perpendicular and bisect. I just extend this one. For this side perpendicular and bisect. For this side perpendicular bisect. So whenever the right angle triangle is there, the circumcenter of the right angle triangle is always lies on the hypotenuse. Always lies on the hypotenuse, and apart from that it is midpoint. Perpendicular circumcenter is midpoint. Right angle triangle is given. For that right angle triangle we need to find the circumcenter, so that midpoint of the hypotenuse side is the required circumcenter of the right angle triangle. Acute angle is there. Whenever acute angle triangle, the circumcenter is lies inside the triangle. Suppose obtuse angle triangle is there. Obtuse angle triangle is there. In that case, the circumcenter is lies outside the triangle. This is the circumcenter of the obtuse angled triangle. So this is all about the circumcenter of the triangle. Next, there is a relation between the orthocenter. Orthocenter, already you know that here is the orthocenter of the triangle, perpendicular, altitudes. So altitudes of the triangle, point of intersection of the altitudes, orthocenter of the triangle. G is the centroid of the triangle, and circumcenter is always denoted by S. Circumcenter is always denoted by S. So there is a relation between the orthocenter, centroid of the triangle, and circumference of the triangle is equal to 3G is equal to 2S plus O. Relation between these 3 points are lie on the same line, collinear. So here the centroid is divides the line segment in the ratio 2:1, so that relation between the orthocenter, circumcenter and centroid of the triangle is 3 times of centroid of the triangle is equal to 2 times of circumcenter of the triangle plus orthocenter of the triangle. This is the relation between the orthocenter, centroid and the circumcenter of the triangle. Then here some of the important points are there. What are the important points is nothing but, so first of all I just take that area of the triangle. Suppose you want to study that area of the triangle. Here next thing is area of the triangle. So area of the triangle we want to discuss means, here the coordinates of the triangle is given A, B, C. A having the coordinate x1, y1, B having the coordinate x2, y2, and C having the coordinate x3, y3. We are required to find the area of the triangle ABC. How do you find the area of the triangle? Different conditions are there. Here vertices of the triangle is given. In such case, how do you find the area of the triangle? There you know the formula. Area is equal to 1 by 2 times of mod of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 modulus. So because area is always measured in the positive quantity, so this is the required area of the triangle. So on simplifying, replacing the value x1, y1, z, x1, x2, x3, y1, y2, y3, it is little bit time consuming, so that we don't have that much of time in the examination. So that required area of the triangle is given by, in such case, is 1 by 2 times of, here determinant of x1 minus x2, y1 minus y2. This is said to be the row, and next one is x1 minus x3, y1 minus y3 square units. This is not a modulus sign. What is this exactly? Is nothing but this is said to be the determinant. So what is meant by determinant? Actually, you are going to come to know that a determinant is nothing but, one topic is that in second PUC you are going to learn this one. Simply I just tell the hint how to evaluate. Determinant is nothing but, it is a real number expressed in the form of rows and the column. First of all, a matrix is that. Matrix is nothing but, this is said to be a rows and these are said to be a columns. Any numbers are expressed in the form of rectangular. Any numbers are expressed in the rectangular array. Rectangular arrangement, they used to express the numbers, that is said to be a matrix. Here there are different type of the matrix are there. First of all, I just consider the square matrix. Square matrix means, first of all you know the square. What is the square? Length and breadth is equal. Square matrix is nothing but number of rows is equal to the number of columns. Here horizontal lines are said to be a rows, vertical lines are said to be a columns. For example, A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Here, these are the 1, 2, 3, row 1, row 2, row 3, column 1, column 2, column 3. This is said to be a 3 cross 3 matrix. That is nothing but 3 rows and the 3 columns are there. This matrix, this is square matrix only, we can rewrite. Another matrix I just write 2, 3, minus 1, 2. How many rows and how many columns are there? How many horizontal line? That is rows. 2 rows are there and 2 columns are there. This is written as a 2 cross 2 rows into columns. Okay. These square matrix I am just going to write in a determinant manner. So I just write the general point, that is A1, B1, A2, B2. First row elements are A1, B1, A2, B2. I am just going to consider only the 2 cross 2. This is a real number. How to get this is a real number means to evaluate this one. After evaluating this one, we will get the real number. How to evaluate? To evaluate, cross multiply A1 into B2 minus A1 into B2 minus A2 into B1. A2 into B1, that will get the required real number. This is said to be a determinant denoted by delta. Determinant is denoted by a delta and given by A1 into B2 minus A2 into B1. This is said to be a determinant. Evaluation of the determinant of the order 2 cross 2. 3 cross 3 determinant evaluation, that is a different thing, little bit lengthy process is that we are going to learn in the second PUC level. At this level, we just remember this thing. Okay, very simply we will get it. So I am just going to solve the few examples based on this one. We will come to know it. So until that, you just remember. Why I am just telling this thing means, if you already know that this result, but substituting and simplifying it takes a little bit of time consumes. So that reason I am just telling the shortcut. Here is the sum, very simply, and within a short period of time we can easily get the answer. So that reason I am just taking this one. This is said to be a determinant. You just write this one. How to evaluate the 2 cross 2 determinant. Second order determinant, how to evaluate. Cross multiply A1 into B2 minus A2 into B1. Diagonally you can multiply the elements, will get the required. First of all, these elements minus of remaining elements diagonally multiply, will get the required 2 cross 2 determinant. So as compared to that one, you just mention it, this determinant, how to evaluate column rows. Next, so here I just written the formula. What is the formula? 1 by 2 into, this is said to be a determinant of x1 minus x2. x1 minus x2 coordinates of the A and B. y1 minus y2, same y coordinate. Next x1 minus x3, y1 minus y3. If we simplify this one, we will get easily the area of the triangle. Area of the any triangle, we will get it. Are you clear? So this is the area of the triangle. Now the next thing is area of the quadrilateral. Or before going to that, whenever the area of the triangle is given, one of the vertex is given. One of the, or example, A having the coordinate 0, 0, B having the coordinate x1, y1 and C having the coordinate x3, y3. The one point or one vertex of the triangle is lies at the origin. Then in that case, how to find the area of the triangle? In that case, area of the triangle is given by 1 by 2 times of modulus of x1 into y2 minus x2 into y1 square units. This is the formula to use the area of the triangle. Whenever a triangle, one vertex is at the origin, remaining for the other than the origin, you can use this one. If you use this formula, nothing to worry, we will get the same answer. So again we will get the, simply we will get the answer. This is all about the area of the triangle. Now next thing is, I am just going to point, if centroid of the triangle is given, in that case how to find the area of the triangle? Suppose G is the centroid of the triangle ABC. If G is the centroid of the triangle ABC, then area of the triangle ABC. So whenever, if they given a centroid of the triangle, directly they used to give the centroid of the triangle. In such case, how to find the area of the triangle? To find the area of the triangle in such cases, here there are different conditions are there. What are the different conditions are there? Means, first of all, I just take the one triangle. Suppose this is the triangle is that A, B, C is the triangle. Now centroid, what is the centroid means? Already you know that G is the centroid of the triangle. Medians, we need to concur. Medians are concurrent, is said to be a centroid of the triangle. Point of concurrence is said to be a centroid of the triangle. Now I need to find this area of the triangle ABC. G is given, centroid is given. In that case, it is sufficient to find that 3 times of the area of the triangle ABC, or ABG. Here I just join all the points. Here a triangle is divided into 3 parts. This is one triangle, this is another triangle, this is the third triangle. 3 is that. 3 times of, we can find that area of the triangle ABG, or else area of the required triangle ABC is equal to 3 times of area of the triangle ACG. In that case, ACG also we can find it, or else area of the triangle is equal to 3 times of area of the triangle BCG. This is, in this manner also we can find the area of the triangle. Now one more very important point. Suppose DEF are the midpoints of the triangle ABC. Suppose in a triangle ABC, ABC is the given triangle. So here D is the midpoint of AB, E is the midpoint of BC and F is the midpoint of AC. ABC is a given triangle. Here D is the midpoint of AB, E is the midpoint of BC and F is the midpoint of AC. In that case, how to find the area of the triangle? So in that case also, area of the triangle we can find. How to find the area of the triangle means 4 times of, I just join these all the midpoints. Here also one triangle will get it. How many triangles? 1, 2, 3, 4. Okay, so here 4 times of area of the triangle ADF. 4 times of area of the triangle ADF, or else we can write 4 times of area of the triangle BDE. To find the area of the triangle, whenever the midpoints they have given, in such case, we don't know if you know the coordinates of the triangle, we can easily find the area of the triangle using the determinant or other formula. So whenever they are given the midpoints of all the three sides, in such case, how to find the area of the triangle? So that case, we can find the area of the triangle as 4 times of area of the triangle. We can say that ADF or 4 times of BDE. If you know this point, midpoint, we can easily find the value. So that 4 times of area of the triangle BD is over, and we can say that CEF also we can find it, or 4 times of area of the triangle DEF also we can find it. This is how there are 4 possibilities are there whenever they are given a midpoint of all the sides is given. This is the another thing to find the area of the triangle. Now, so again the area of the triangle, whenever all the 3 coordinates have 1 by A comma 1 by A, B comma 1 by B, and C comma 1 by C. Suppose the ABC is the triangle, the vertices of the triangle is given as A comma 1 by A, B comma 1 by B, and C comma 1 by C. So A is a reciprocal y coordinate, x coordinate is B, y coordinate is reciprocal of that one, x coordinate is C, reciprocal of that one is the y coordinate. In such case, the vertices of the triangle is given. So how to find the area of the triangle? So area of the triangle is equal to modulus of A minus B into B minus C into C minus A. Cyclic order, you just take that A, B, C. Cyclic order, you just take the A, B, C, A minus B, B minus C, C minus A, divided by 2 times of A, B, C square units. This is how we are required to find the area of the triangle whenever the vertices of the triangle is given in this manner. Are you clear? Now go to the next point, area of the quadrilateral. Suppose on quadrilateral is that, what is meant by quadrilateral? 4 sides and 4 interior angles. So here area of the quadrilateral is that, how to find? All the vertices they are given, A having the coordinate x1 comma y1, B having the coordinate x2 comma y2, C having the coordinate x3 comma y3, and D having the coordinate x4 comma y4. 4 points, 4 vertices of the quadrilateral is given. In that case, how to find the area of the quadrilateral? Whatever it might be, area of the quadrilateral is equal to, so this is given by, once again the same as you people used to find area of the triangle, in the same way we can find the area of the quadrilateral using the determinant. How to use? 1 by 2 times of determinant of, I just write the x coordinate difference, that is x1 minus x3, and similarly y coordinate difference y1 minus y3. This is the first row. Second row is 1 3 is over. Now come for the 2 and 4, that is x2 minus x4. Similarly y coordinate y2 minus y4 square units. This is how we can find the area of the quadrilateral. Whenever all the vertices of the quadrilateral is given, area of the quadrilateral is given by 1 by 2 times of determinant of x1 minus x3, y1 minus y3. First row. Second row, x2 minus x4, y2 minus y4. X coordinate difference, y coordinate difference, odd points, even points, we can find it. Alternative points, we can take the x coordinate difference, y coordinate difference, 2 rows. To evaluate this result, how will you do? Cross multiply diagonal elements, minus of remaining 2 diagonal elements, cross multiplication will get the required area of the quadrilateral. Suppose this is the quadrilateral is the ABCD. How to find the area of this quadrilateral? So we need to take one diagonal, then this is the triangle, this is the triangle. Sum of these 2 areas of the triangle will get the area of the quadrilateral. So in such case, whenever the vertices is given, we can use this as the simple formula to find the area of the quadrilateral. So again, area of the equilateral triangle. area of the equilateral triangle. Equilateral triangle is nothing but what? Equilateral triangle. All the three sides have the equal in length. So ABC is the given triangle. Given triangle. So side length of AB is A unit. Side length of BC is also A unit. Side length of AC is also A unit. Then interior angle, three angles all are equal to the 60 degree. All are equal to the 60 degree. This type of triangle which is called as a equilateral triangle. In such case, what is the area of the equilateral triangle? That is root 3 by 4 into a square. Root 3 divided by 4 into how much? A square, where a is the length of the side of the triangle. This is the required area of the equilateral triangle. Are you clear? Now the next point is acute angle triangle. Acute angled triangle. What is the acute angled triangle? Acute angled triangle means all the three angles of the triangle are less than 90 degree. All the three angles of a triangle are less than 90 degree. That means triangle is the three sides are there, three angles are there. All these three angles are less than 90 degree, 0 to 90 degree there. Then we can say that that triangle is acute angled triangle. Similarly, obtuse angled triangle. What is the obtuse angled triangle? Out of the three angle, one angle is the obtuse angle. Out of the three angle, if any one of the angle is obtuse angle. Obtuse angle means that angle lies in between 90 to 180 degree. Such type of the triangle we call it as a obtuse angled triangle. So acute angle triangle means out of all the three angles are less than 90 degree. Obtuse angle triangle means out of the three angle, one of the angle is a obtuse angle, but that is more than 90 degree. So whenever vertices is given, how to verify that a given triangle is acute angle or obtuse angle? So for that, I just take that, name that ABC is a triangle. So here ABC is a triangle. I need to verify that acute angle triangle. I just write the condition. So here we are required to verify that it is an given triangle is the acute angle triangle. So it might be satisfy any of the condition, that is AB square plus BC square is greater than AC square. AB square plus BC square, AB side length square plus BC side length square, sum of the two sides length square is greater than the third side length square. That is said to be, if this condition is satisfied, then you can say that it is a acute angle triangle. Or else second condition we can say that BC square plus CA square is greater than AB square. BC square plus CA square is greater than AB square. Or one more possibility is there. What is the one more possibility? CA square plus AB square is greater than BC square. CA square plus AB square is greater than BC square. If out of these three conditions, if any one condition is satisfied, then we can say that the given triangle is a acute angled triangle. Why I am just telling this condition means they used to give that coordinates, A coordinate, B coordinate and the C coordinate, and they used to ask that verify or check whether given triangle is an acute angle, obtuse angle, right angle or just a triangle. They used to ask it different model. So that reason, whenever you are going to check the acute angle, out of any one of the three conditions should be satisfied. If any one of the condition is satisfied means we can easily say that given triangle is a acute angled triangle. Are you sure? Now come for the obtuse angled triangle. Obtuse angle triangle means, as we discussed earlierly, that is out of the three angles, one angle must be obtuse angle. Out of the three angle, one angle must be the greater than the 90 degree. Here I just taken a ABC. I am just going to write the one of the condition. In one condition, it has the three possibilities are there. What are the three possibilities? I just write that, just name, little bit change the name, A, B, C. You can easily understand. Now I just write that AB square plus BC square is greater than AC square. And apart from that, as you people written here all the three possibilities, the same three possibilities, you just write it. What are the three possibilities? AB square plus BC square is greater than AC square. Similarly, cyclic order you can write that BC square plus CA square is greater than AB square. Or else other thing we can write as CA square plus AB square is less than BC square. Is less than BC square. How I am just going to write? Are you following? AB square plus BC square is greater than AC square. Apart from that, BC square plus CA square is greater than AB square. Next, apart from that, CA square plus AB square, CA square plus AB square is less than BC square. Here three possibilities are there. All the three possibilities just write it. In a two possibilities, greater than sign, one case is less than sign. This is one case. Another case is, this is the first possibility. Second possibility is nothing but here the same thing I am just going to write. AB square plus BC square is greater than AC square. BC square plus CA square is less than AB square, and CA square plus AB square is greater than BC square. This is the second possibility. Either this one or this one. One more is there, third one. What is that one? The same thing you just write it, but little bit change the inequality sign. AB square plus BC square is less than AC square. BC square plus CA square is greater than AB square, and CA square plus AB square is greater than BC square. This is one possibility, this is one possibility, this is one possibility. Out of these three possibilities, if any one condition is satisfied, this is one condition, this is the condition number 1, this is the condition number 2, this is the condition number 3. Out of these three conditions, if any one condition is satisfied, then you can say that a given triangle is the obtuse angled triangle. So how to get these all the things? Have you confusing? No need to confuse it at all. So how to write? Cyclic order is just write the side length square. So two side length, two case here, the two things greater than sign, one thing less than sign. Two things greater than, one thing is less than. Two thing is greater than, one thing is the less than. So if this condition is satisfied, then we can say that a given triangle is obtuse angled triangle. Easily we can conclude it. Okay. Now the next thing is types of quadrilateral. Types of quadrilateral. There are different types of the quadrilateral is there. In that, first of all, parallelogram. In that, first of all, parallelogram. So already know that parallelogram. What is the condition of the parallelogram? Usually used to say that there are two set of parallel lines. There are two set of parallel. This is A, B, C D is the parallelogram. Then AD is parallel to BC, AB is parallel to CD. So we need to conclude that a given quadrilateral is parallel or not. Parallelogram or not. For that, here the some points are there. What are the some points? Is nothing but midpoint of AC is must be equal to the midpoint of BC. Midpoint of AC is must be equal to the midpoint of BD. That means diagonals midpoint are must be same. Not only this condition, next condition. What is the next condition? Means this is one thing. Next thing is AB square plus BC square is not equal to the AC square. AB square plus BC square is not equal to the AC square. This condition should be satisfied. Next, apart from that, third one, what is the third one? AB square is not equal to the BC square. AB square is not equal to the BC square. If these three conditions are satisfied, then we can easily say that a given quadrilateral is a parallelogram. Now let's come for the rhombus. When we need to say that a given quadrilateral is the rhombus, that is nothing but the same thing. Second one is the rhombus. So we need to conclude that a given quadrilateral is a rhombus. How do you conclude that? Rhombus. This is the rhombus we need to conclude it. Then what is the necessary thing to check it? Here the same thing. Again diagonals, diagonal midpoints of the each diagonal, yes, satisfy. The first condition is satisfied. That is midpoint of AB is equal to the midpoint of BC. Midpoint of AB, not AB, midpoint of AC is equal to the midpoint of BD, diagonals midpoint. Next thing is, we can say that AB square plus BC square is not equal to the AC square. AB square plus BC square is not equal to the AC square. Third condition, can I say that adjacent sides are equal in length? Adjacent sides are equal in length. AB square is equal to the BC square. Adjacent sides have the equal in length. So this is said to be a rhombus. Have you come to know that what is the difference between the parallelogram and the rhombus? In the parallelogram and the rhombus, midpoints of the diagonals are same, and Pythagoras theorem is not satisfied because here it is not possible to get the right angle triangle. Here adjacent sides are not in a equal length. Here midpoint of the diagonals are equal. Pythagoras theorem is also not satisfied, and adjacent sides are in equal in length. Now the same thing, third one is, suppose if you want to say that a given quadrilateral is a square, then these three conditions only we need to check it. What we can say that midpoint of the diagonals are satisfied? Yes, midpoint of the diagonals are equal. Second one, Pythagoras theorem is satisfied? Yes, obviously Pythagoras theorem is also satisfied. Yes, we can say that. Third one, adjacent sides are equal in length? Yes, adjacent sides are equal in length. All the three conditions are satisfied. Then you can conclude that a given rectangle is a square. Next one is, fourth case is a given quadrilateral is a square. Next one, rectangle. Next one is a rectangle. When we need to say that a given quadrilateral is a rectangle, to say that rectangle, first one, midpoint of the diagonals are equal. Midpoint of both the diagonals are equal. Yes, obviously midpoints of both the diagonals are equal. Second one, Pythagoras theorem is satisfied. Yes, Pythagoras theorem is also satisfied. Pythagoras theorem is satisfied. Third one, what is the third one? Adjacent sides are in equal in length in the rectangle? No, adjacent sides are not equal in length. So this is how we need to check that given quadrilateral is a square, a rectangle, rhombus or a parallelogram. These common 3 points we need to check it. So which one is going to satisfy? We need to check it. If you remember the diagram, you can easily check these conditions. So this is how we need to get it. Now next one is very important point, that is, whenever they are given a centroid of the triangle, centroid of the triangle is given and the two vertices is given. Suppose A, B, C is the triangle, centroid of the triangle. Centroid of the triangle is nothing but G is given. Now here centroid of the triangle is given and the two vertices of the triangle is given. We are required to find the third vertex A. How to find the third vertex A is nothing but I just name the things. How to name this means, this I just call it as a x1 comma y1, this is x2 comma y2. Centroid I just named as a x0 comma y0. We are required to find the coordinates of the A. how to find the coordinates of the A? Coordinates of the A I just call it as x3 comma y3. Now the x3 comma y3 can be written as, what is the x3 value? Centroid of the triangle is given, 2 vertices is given. How to find the third vertex? 3 times of x0 minus x1 minus x2. How to find the third coordinate? 3 times of x0 minus x1 minus x2. Similarly, y coordinate 3 times of y0 minus y1 minus y2. This is how we can find the third vertex of the triangle. Have you got my point? Whenever the centroid of the triangle is given and the 2 vertices of the triangle is given, we are required to find third vertex of the triangle. Third vertex of the triangle remaining, whatever they can give a and b, we need to find the c, or they can give the ac, we are required to find the b is nothing but this is a formula we need to find. 3 times of the centroid x coordinate difference y, difference of the remaining 2 coordinates of the 2 points. So that is 3x0 minus x1 minus x2, 3y0 minus y1 minus y2. So this is the one thing. Next thing is, in a triangle ABC, they given a midpoints of the triangle DEF. So D is the midpoint of AB, E is the midpoint of BC, F is the midpoint of AC. Then we can easily find the, whenever the midpoints are given, we can easily find the coordinates of the triangle. How to find the coordinates of the triangle? Means coordinate of the triangle A is equal to, whenever the midpoints of the triangle is given, then midpoint of all the sides of the triangle is given. How to find the coordinates of the triangle? A coordinate if you need. How to find? Sum of the nearest points of the A. Sum of the nearest point of A. What are the sum of nearest points of the point A? D plus F, and difference of the farther point. So whenever midpoint of all the 3 sides is given, we are required to find the coordinates of the triangle A. Now, coordinates of the triangle is required. A coordinate is required means for the A point, which midpoints are nearer? D and F are nearer. Add those two. Which one is long distance? E distance is that is E point, subtract it. Suppose if you want to get the B coordinate, the same thing formula you need to apply. Nearest, sum of the nearest midpoints and difference of the third one. What are the nearest points, midpoints of, what are the nearest midpoints to the B? Nearest midpoints are D and E. Further one is F. Similarly for the C point, which are the, what are the nearest midpoints? E and F. E plus F minus D. This is how we can easily find the coordinates of the triangle whenever the midpoints of the triangle is given. Then the next thing is, suppose in a parallelogram, suppose one parallelogram is given. If they given a parallelogram, this is the parallelogram they are given, ABCD. ABCD is the parallelogram. A having the coordinate x1 comma y1, B having the coordinate x2 comma y2, C having the coordinate x3 comma y3, and D coordinate we don't know. To find the D coordinate, I just call it as the x comma y. We are required to find the x comma y. So how to find the x comma y is nothing but to find the x and y value. So what is the thing? For the parallelogram, they given a 3 vertices. We are required to find the 4th vertex. To find the 4th vertex, how will you get? Means conjugative point sum. Conjugative point sum is nothing but x1 plus x3 minus of the remaining thing. Conjugative points x coordinate sum, and similarly for the y coordinate conjugative term sum, and remaining term you just write in the difference. You just write in the difference. That will get the required 4th vertex of the parallelogram. X value x1 plus x3 minus x2, y1 plus y3 minus y2. Whatever it might be, we are required to find the D or A or B or C, whatever we can find it. So for that D is that, so D is required. Next here this point nearest point for D, this one, you just add those two, and opposite to that one you just subtract it. In that way we can find it. So this is how we need to find the vertices and coordinates of the triangle and parallelogram, like that. So till so far we just discussed all the synopsis of the 2D geometry. So try to remember all these shortcut hints apart from the theory part. In the next video I am just going to start directly the level 1 questions. If you remember all these things, we can easily solve any problem by using some of the shortcut hints, or regular theory class concept also we can use it. If you use the theory class concept, it little bit time consuming while solving the CET problems. So that reason I am just suggest you that remember all these concepts. Okay, we will continue in the next video. Thank you.